Greetings, hexRD users. In this first video in the TARDIS Analysis series, I'm going to step through the procedure for importing raw data from the NIF-SHOT archive into the program. So we start by opening the hexrdgui. I'll note that this version that we're using is 0.9.5, so I strongly suggest getting up to date because some of the features might not make sense or there might be bugs in some previous releases. So once the program is up and running, the first thing that I do is go here to the File menu, go to the Import submenu, and then select this descriptively named LLNL Import Tool item. So when I hit that, it brings up this new widget here with the same name that is laying out a serial workflow for getting the raw image data into the program and associating it with the right detector object. On a practical note, I'm going to strongly recommend that you take this widget and you dock it in the main window. And you can dock it wherever you want. You can see if you drag this thing around where it starts looking dark like that, it's meaning that it's going to just slurp it into a tabbed widget wherever your mouse is hovering over. The reason for doing this is that it prevents you from having to keep on clicking back and forth between this window and the window underneath to raise focus to do things like drag around a crop boundary. So I think that it makes the most sense to dock this thing before starting the procedure. I'm going to maximize here so it gives us a nice big graphics canvas to work with. And let's start stepping through the procedure. Notice that the only thing I can select here, again, this is kind of serially guiding you through the process to get the data in here, is I first have to pick what instrument I'm dealing with. Now, there are only two selections in here, this TARDIS and PixarDip. We'll cover PixarDip imports in a separate video. I'll note that this TARDIS instrument is specifically the TARDIS C2 instrument. So maybe I'll update that title in there at some point. We can add more instruments to this list and use this procedure as a template for how we might import other image plate data, but that obviously would be on the scope of this video. Now, next option that we have here is picking where the configuration for the actual instrument is coming from, where the parameter values that describe the actual instrument are coming from. And for TARDIS, with pretty much no exception that I can think of, we always want to start with the default configuration. You can, if you have already loaded a configuration for a TARDIS instrument, you can go in here and just select what's already loaded. Now, I don't have a TARDIS instrument already loaded in this instance of the GUI, so that's not going to be what I want to select. And if you want to load a configuration here and you uncheck the default here, you have to actually go and select an instrument configuration that you want to use. Now, again, for TARDIS data, I really don't recommend loading a configuration that's different from the default, since the reference dimensions for everything are pretty tight. So it's my recommendation for TARDIS that you always select load configuration and make sure that you have this default checkbox selected. So now the next item that it lets us do here is select a raw image. And these raw images are actually the HDF5 files that are in the shot archive for NIF. For this shot, I'm looking at the ABX shot that was one of mine from ages ago. And it happened to have HDR images in the shot archive. So I'm going to start with image plate 2, which is the bottom image plate in the TARDIS. And when I select open, the first thing that comes up is this load dialog here that gets used in other parts of the program. It echoes which file I loaded here that I can see, and lets us, in this case, the import tool is going to take care of associating this image with a particular defect detector. So that column's not particularly descriptive in this case. But it does allow you to apply a transform to this image upon load. Now, you don't have to do this here because we can do it later in the process. You can do it here. You can kind of shortcut and do it here if you want to. I will note that every scanned image plate that I've seen, whether that's in Pixardip or TARDIS or BBXRD, they always require a mirror operation to bring it into the reference coordinate system that hexRD uses, which is from the X-rays point of view, as if you were looking at the active surface of the image plate. So the scanner applies an inversion that can be corrected by applying a mirror operation. You can see that there are basically three of these operations that's providing here are mirror operations. You can mirror both the vertical axis, the horizontal axis, or transpose, which is a mirror plus 180-degree rotation. Don't worry about selecting that here. Most of the TARDIS data I've seen always has the same sequence of how you do the mirrors, but we'll get into that a little bit later. So once I hit OK there, it brings up another dialog. And this is for a fresh version of the GUI where I haven't saved common paths that I'm using. And it's basically because the image I'm loading is an HDF5 archive, it's expanding all the paths that are in the HDF5 archive. For NIF data, the actual image array itself is always under this data group. Now, the exact path to get here depends on whether it's an HDR image or if it's one of the PSL fade corrected images. Now, I think it's just the second item in the directory here. Instead of saying HDR image, for example, one of the corrected image, I think it says like core image or image plate core. But the image is always under data, and that's the one I want to select. If I select this here, remember this path, it's going to basically add this to a known path that if I load this image again in the future or do the import, it's going to automatically follow this path to the data. So that's up to you whether or not you want to select that. If you restart the GUI with the flag that ignores previous settings, then it's going to clobber that anyways. If I hit OK, and there we are. There's the raw image loaded. I'm going to change the scaling here so that I can see the boundaries pretty well. You can mess with the color map so that you can see the whole thing, because the next thing that we have to do is associate this with the underlying detector, which is image plate 2 in this case, and then perform the crop operation to take the actual active pixels from the detector into a region that's smaller than the full scan region, which in this case is, I think the NIF arrays are always 750 rows by 1250 columns. But that's not particularly important because you could import any HDF5 file that you had saved. It doesn't really matter what the dimensions are. But what we need to do here, notice that this next option here under the raw image called association has become active. And what I need to do here, because the data doesn't tell me explicitly in a header automatically, is that you have to manually associate which detector this image belongs to. Well, I know that this is an image from image plate 2, so I want to associate this, the current detector, I want to make sure it's set to image plate 2. Notice that the only options here for TARDIS currently are image plates 2 and 4. It's because the rind did not make it into this particular release. But in a future release when the rind is in here, the procedure is going to be exactly the same for the rind as well. But this is image plate 2, so I want to plop down the detector outline. So immediately you can see this detector outline is plotted in the proper internal coordinate system. Obviously, you see that we have to mirror this image about the horizontal to get it to line up with the reference coordinate system. And that's obvious because of the placement of the hole and the shape itself here. And remember, I said if you already knew that you had to mirror image plate 2 about the horizontal, you could have applied that upon load, but not to worry, because we can actually apply that here once we've actually drawn the detector outline by adding a transform to the image. So I want to mirror about horizontal. Click that, and there we are. Aside from just translating our detector to line up with the boundaries of the image plate, we're now in the right coordinate system. So the next option that became active here is basically our crop tool. It gives us two transformations for dragging around this detector outline to define our crop region, and that's translate and rotate. And the inputs for how we change this is there's this an interactive canvas, so you can use click and drag with the mouse to do a fairly coarse alignment, and then the arrow keys up, down, and left, right basically do your fine alignment of for this translation steps. I think it's something like half a pixel. You can see that's already pretty close. Now, as far as the rotation goes, there is a bug currently in the tool that's more of an annoyance than a showstopper, that if you apply the transformation in sequence using this tool instead of on load, if you try to go in here and rotate the image outline, it disappears. This one's a head scratcher. We're going to try to get it fixed soon. But don't worry about it too much. If you forget and you do this and you try to drag with the mouse to rotate and it disappears, you can cancel this and you can add the detector outline again. It will redraw it, and you can kind of start the procedure again. I still selected rotate. So let me do translate again. Here we go. Yeah, that one's a head scratcher, and we'll get that fixed soon. But the good news is that while for some reason the current version with the current version of Matplotlib that we're using and everything, the rotate after applying the transform this way makes the outline disappear. The arrow keys work fine. So if I select rotate here and I do arrow key input, you can see that I'm rotating that image plate boundary for doing my cropping. It depends scan to scan. The translations are all over the place within like the scanned region and the NIF archives, but the image plates are usually pretty square. I'd say they're all usually within a degree of being square, where this bottom edge is at least parallel to the bottom edge of the scanned region. But you can do fine tuning with the arrow keys like I just did there to get it lined up a little better. You don't have to sweat this procedure too much in terms of how well you get this boundary lined up. This is fine. Any of the uncertainty here or misalignments are going to get absorbed when we do the calibration later on in translation degrees of freedom. So I'm happy with how this is aligned. I hit OK. It brings me on to the next section here. You do have the ability, if you want to, for drawing figures or something, you can actually change the size of the bounding box here for the detector and the color that it's drawing the lines, but not necessary to do the import. So notice what happened is that once I accepted where the detector outline is here, image plate 2 has gotten added to this list of completed detectors down here. So we can continue to add detectors as we see fit here. There might be some cases, and this happens in Pixardip at least, where for some reason one of the image plates is damaged and you only have one image plate or one good image plate. You could stop here and load the instrument and just have image plate 2. Or we can continue to go back through this process again and add our next detector. So in this case, I'm going to add image plate 4. Again, we don't have the rind in this release because it just didn't make it in terms of the list of features that we had in here, but we do have image plate 4. Now I'm going to, just for sake of showing you the different ways that you can do this, I know that image plate 4 typically needs to be mirrored about the vertical. Image plate 2 needs to be mirrored about the horizontal. Image plate 4 needs to be mirrored. Well, if you mirrored about the horizontal, you'd have to mirror it and then rotate it 180 degrees. But you can do that same operation just by mirroring about the vertical. So I load this. Notice that image plate 4 gets loaded in here. I have to make my one-to-one association that this image belongs to the object image plate 4 in my detector. I hit detector outline. You see, because I applied that that mirror, that it already is lined up in the right sense with regards to the internal coordinate system here. Notice that because, and this is the case where the bug doesn't show up, because I loaded it and did the transform on load instead of using the widget here, when I rotate with the mouse, it actually works. But again, the arrow keys always work, so I wouldn't sweat it too much. Line this thing up. That looks good. Hit OK. Now see that image plate 4 has been added to my list of completed detectors. I don't have any other detectors to add at this point, so I say complete and reload instrument. And this is going to take a second, as it's basically initializing internally an instrument object with these images associated with the proper detectors, image plates 2 and 4. This takes a second because it's calculating things like Bragg angle extents and pixel sizes. So once the images are loaded here, they show up in this raw view, and there's an axis for each image that we imported. I can select this tabbed option if you want to look at the raw data by itself. You can play with the color map if there's things that you want to look at here. There's not too much that we're going to be doing with these until we start working with the calibration and adding material overlays. And that will take us to the next video. Thanks for watching.